Okay, may I audible to you?
Yes,
Yes.
sir.
And my screen is visible?
Yes, sir.
Okay, fine. Thank you. So today we are going to start the unit number 5, that is thermal radiations. Okay. So in this session, okay, or in this unit, basically we are going to cover the fundamental concepts of radiative heat transfer, then spectral and total emissive power, okay, real and gray surfaces, because radiation is a surface phenomena. So the nature of the surface, whether it is rough, whether it is finished, or uh, gray or real, that basically matters here from radiative heat transfer point of view. Then we are going to learn the different laws of radiation, that is Stephen Boltzmann law, Planck's law, Wien's law, Kirchhoff's law, and Lambert cosine rule, okay, with simple applications. Then irradiation and radiosity, these are the important concepts. Then, just like we have used the electrical analogy to solve the conduction and the convection problems, okay, or conduction convection problems uh, in the first unit, same electrical analogy we have to use to solve the radiation heat transfer problems. Then radiation shape factor, radiation heat exchange between two surfaces, and radiation shield. Okay, so these topics we have to cover in this unit number 5. Okay, so let us start with the fundamental things. Okay, so what do you mean by thermal radiations? Okay, so radiation is basically the important mode of heat transfer. Okay, and in radiation there is a transfer of heat energy that is due to electromagnetic waves. Okay, without requiring any medium, without requiring any physical contact. Okay, whereas in convection as well as in conduction, in conduction, there is a molecule to molecule heat transfer takes place. These molecule, two adjacent molecules that are in contact with each other. Okay, so high energy molecules gives energy to the low energy molecule. Okay, so the exchange of energy takes place, or the exchange of heat takes place. So there is a contact of these two molecules in the conduction. Whereas in the convection, there is a transfer of heat from surface to the surrounding fluid. So there is a that fluid molecule is basically in contact with the surface. Okay, so there is a basically contact of molecules as well as the contact between surface and the fluid molecules in convection. Okay, so conduction and convection, there is a contact. Okay, here there is no contact, still there is a transfer of heat that is takes place with the help of electromagnetic waves or due to electromagnetic waves. So in short, we can say that there is a transfer of heat that is due to electromagnetic waves, and without any physical contact, without any medium. No medium is required here. Okay, so that is known as a thermal radiation. Okay, so different theories of radiation. Okay, so there are two theories that are used uh, or widely accepted basically. First one is the wave theory, that is also known as the Maxwell theory, and second theory is known as a quantum theory. It is also known as a Planck's theory. Okay, so now we'll see the details of these two theories. So first one is the wave or the Maxwell theory. Okay, so basis of this theory is the electromagnetic waves, and there are different types of electromagnetic waves, and all the types of waves are basically carrying the energy. Okay, and it travel at different wavelength. Okay, so there is a relationship between wavelength, velocity, and the frequency, because every wave is having a wavelength. Okay, it is having a frequency. Okay, so in conclusion, if we can say that if we have two surfaces, okay, one surface is uh, My hand is, are you visualizing my hand? Yes?
Yes, sir.
Okay. So if you have two surfaces, this one is maintained at a 200 degrees Celsius, and other surface is maintained at a some 50 degrees Celsius. Okay, these two surfaces are not having any physical contact. Okay, so this is maintained at 200, this is maintained as 50. So there is a transfer of heat from, obviously because of delta T, from 200 degrees Celsius to 50 degrees Celsius. Okay, but in radiation, you have to keep in mind that every surface is basically radiating energy, or every surface is basically radiating the heat. Okay, so this surface is also radiating heat, this is also radiating heat. Okay, now there is no physical contact of these two surfaces. Still, there is a transfer of heat from this surface to this surface, okay, or this surface to another surface, okay. So that is because of radiation. Okay, so there is no medium basically required, and there is no physical contact is basically required. Okay, so this kind of transfer of heat is known as a radiative heat exchange or the radiative heat transfer. Okay, one more example I am telling you, that sun is basically located at a very uh, um, high distance from the earth surface. So there is a sun surface, there is a earth surface. Okay, so sun is maintained at a temperature around 5800 Kelvin, and we are receiving the energy from the sun. Okay, though these two surfaces are having in between that there is a huge distance. Okay, so still we are getting the energy, that is because of the radiation. Okay, now in Max or the Max wave or the Maxwell theory, basically the basis is the electromagnetic wave. Okay, so energy or the that wave are basically carrying energy. Okay, and a wave is having a wavelength, it is having a frequency, okay, and it is having a velocity. So there is a relationship between wavelength, velocity, and the wavelength, velocity, and the frequency. Okay, so wavelength is basically equal to the velocity divided by the frequency. Okay, and these waves, okay, the waves are basically carrying energy from one surface to another surface. Okay, and this theory is basically its base is on the electromagnetic wave. So velocity of light in vacuum, velocity of light in vacuum, as you know, it is around 3 into 10 to the power 8 meter per second. Okay, and generally this wavelength is specified in terms of micrometer. Okay, and one more important thing is that thermal radiation increases with increase in temperature. Thermal radiation increases with increase in temperature. So I am recalling that example. One surface is maintained at 200 degrees Celsius, another is maintained at 50 degrees Celsius. Can you tell me which surface will radiate more energy?
The
Yes.
surface which have temperature 200 degrees Celsius.
Yes. So surface which is having a temperature 200 degrees Celsius, that will radiate more amount of heat compared to the maintained at 50 degrees Celsius temperature. Okay. It doesn't mean that 50 degrees Celsius temperature surface is not radiating heat. It is also radiating heat, but in comparison with 200 degrees Celsius, it is lower. Understood? Yes? Hello?
Yes, sir.
Huh. So, so what happened? As both surfaces are radiating heat, so we are interested to the net amount of exchange of energy between the two surfaces, because this 200 degrees Celsius surface is radiating suppose Q1 amount of heat, and 50 degrees Celsius is radiating Q2 amount of heat. Okay, so we are basically interested in the net amount of exchange of heat because of the radiation. Okay, and these two theories that are widely expected, first one is the wave or the Maxwell theory, and another theory is the quantum theory, that is also known as the Planck's theory. Okay, so this theory is based on the concept that radiation emission are in the form of series of entity. So that series of entity is known as a quanta, and that is also known as a photon. that is also known as photon. So it is just like a similar to in last theory there is a wave, so here there is a quanta, or you can call it as a photon. So each quanta or photon possesses certain amount of energy. Each quanta or photon possesses certain quantity of energy, and that is proportional to its frequency. That is proportional to its frequency, and this quanta moves with the speed of light or the velocity of light and releases its energy. Okay, and so according to this theory, the thermal radiation basically propagate in the form of this quanta, and each quanta having an energy of E is equal to H into this nu. Okay, and what is nu? Nu in last case we have seen this nu is known as a yes,
Frequency.
yes, nu is known as a frequency, and that is equal to frequency multiplied by this H. Understood? So, and similar equation that in last case we have seen, that is nu is equal to C upon lambda, where lambda is the wavelength. Okay, so this nu is replaced with this C upon lambda, and now if you see this equation carefully, you will find that energy basically possesses by that quanta, that is inversely proportional to the wavelength and directly proportional, okay, to this C. Okay, and H and C are basically constant for that medium, since the C is the velocity of the light, and that is equal to 3 into 10 to the power 8 meter per second. Okay, so for this reason the short wave radiations have much higher photon. Short wave radiations have much higher photon, or you can say that the short wave radiations, okay, that are basically have the more temperature. Okay, so generally the lambda is inversely proportional to the temperature. Okay, so short wave radiations have much higher photon energy as compared to the long wave radiation. So I am again recalling that example. The surface which is maintained at a 200 degrees Celsius, and another surface is maintained at a temperature 50 degrees Celsius, that is 50. So which surface is radiating the wave having short wave, and another is having a long wave? So which is having long wave and which is having a short wave radiation? Yes. Hello. Can I repeat question?
Yes, sir.
See, there are two surfaces. One is maintained at 200 degrees Celsius. Another is maintained at 50 degrees Celsius. Okay. So which surface is having a higher photon energy?
50 degrees Celsius.
कसं 50 डिग्री असणार आहे? Higher photon means higher temperature, ना? So higher temperature surface is basically having a short wave, and lower surface temperature is having a long wave. Got it? Yes or no?
Yes, sir.
See,
Yes.
higher temperature surface is having a short wave radiations, and lower surface temperature is having a long wave radiations, because the short wave radiations have the much higher photon energy. So 200 degrees Celsius surface will radiate more energy compared to the 50 degrees Celsius temperature. So the short wave radiations will have the much higher photon energy, and because of that, that is radiating more amount of heat compared to the low temperature surface. Got it?
Yes, sir.
Okay, fine. Then now the emissive power of a surface. Okay, now in conduction as well as in convection, we have seen the concept of heat flux. What do you mean by heat flux? Yes, what do you mean by heat flux?
Amount of heat energy transfer per unit area.
Yes, Q by A, rate of heat transfer due to conduction or convection divided by area. That is known as a heat flux. Okay. So emissive power is similar concept like a heat flux. Okay. So here also the total emissive power of a surface is defined as the emissions of the thermal radiation. Emissions of the thermal radiation means it is a rate of heat transfer due to radiation. Rate of heat transfer due to radiation by a surface per unit time per unit area. So emissions of a thermal radiation by a surface per unit time, this is basically the watt. This is basically the watt means it is the rate of heat transfer. Per unit area, that is a meter square. So it is a Q divided by area. It is a Q divided by area, and Q by A is known as a heat flux basically. But in radiation, this heat flux is known as a emissive power of a surface. Emissive power of a surface, because radiation is a surface phenomena. Radiation is a surface phenomena. Okay. So the emissive power of a surface is defined as the emissions of the thermal radiation by a surface per unit time per unit area, or in other way you can make this definition as a rate of heat transfer due to radiation, that is Q, rate of heat transfer due to radiation per unit area, that is known as emissive power of a surface. Got it? Yes.
Yes, sir.
So higher the area, Q by A basically. Okay. Q by A is more when Q is more. And when Q is more, if the surface is maintained at a higher temperature. Understood? Yes? Hello?
Yes, sir.
So rate of heat transfer from any surface, okay, it depends on mainly temperature. It depends on temperature, it depends on the area, okay, and it depends on the whether the surface is rough or whether the surface is finished. Okay. So emissive power is the equivalent term to the heat flux that we already learned. Okay. So E is equal to basically dq upon dA. Okay. So in order to get total emissions from the finite surface area, okay, per unit time we can integrate. We have to integrate, then and then we will get the this Q. Now this Q is basically you will get either in joule or in kilojoule. Okay. So basically this Q divided by the time, that we are calling it as a rate of heat transfer. So the total emissive power of a surface depends on temperature of the surface, its material, and surface finish. Understood? So it depends on the properties of the surface. The total emissive power or the rate of heat transfer due to radiation depends on the properties of the surface. That's why radiation is known as a surface phenomena. Yes, have you got this?
Yes, sir.
Okay, fine. Now, irradiation of surfaces and radiosity. Irradiation of the surfaces and radiosity. Okay. Now, irradiation means what? Before that, I just want to know whether have you understood that three important term or not. Okay. That is absorptivity. Okay. Then reflectivity and transmittivity. Do you know these three terms? Yes. Hello.
Yes, sir.
What do you mean by absorptivity?
The amount of heat absorbed by the per unit area.
Uh, no, this is not a correct thing. Can anybody tell? What do you mean by absorptivity, reflectivity, and transmittivity? So as it is covered in the first year engineering, so I have not basically included here.
So absorptivity. Hello. Hello. Hello.
Hello, hello.
Yes, sir. Audible.
Uh, yeah. So there was a little bit net issue. Uh, so can anybody tell absorptivity, reflectivity, and transmittivity? Then we'll discuss that
Yes,
radiosity
sir.
and irradiation. Okay. Yes.
Yes,
Who
sir.
will tell?
So absorptivity, the amount of radiant energy absorbed by body per amount of radiant energy incident on
Yes.
body.
So total amount of radiant energy incident on that body. Okay. That is at denominator. That is at denominator. Whereas the amount of heat that has been absorbed, that
Radiant
radiant
energy.
energy absorbed, that is at numerator. Got it? Okay.
Yes, sir.
Uh, let me start that presentation. Yes. Slide is visible. Hello.
Yes, sir.
Okay.
Visible.
So see the Q amount of heat. or the radiant energy that has been falls on the surface. Out of that Q, if QA amount of heat get absorbed by the surface, so QA divided by Q, that is known as absorptivity. Understood? Yes?
Yes.
Yes,
Okay.
sir.
Similarly, out of that Q, if QR is reflected from the surface, so QR upon Q, that is known as a reflectivity. Okay. And similarly, the QT, if it is get transmitted from the surface, so QT divided by Q, that is known as a transmittivity. Understood? So absorptivity
Yes, sir.
plus reflectivity plus transmittivity is equal to
Total radiant energy.
total is equal to 1.
Yes, yes, sir.
Absorptivity plus reflectivity plus transmittivity is equal to 1. Understood? Yes.
Yes,
Yes,
sir.
sir.
Okay, fine. Now the next two terms, that is the irradiation and radiosity. So irradiation of the surfaces is defined as the total radiant energy received. See, total radiant energy received per unit time from all directions. Total radiant energy received per unit time from all directions. So let us consider one surface. Okay. So if this surface, because see, every surface radiates energy in all directions. Every surface radiates energy in all directions. Okay. And the surface is also receiving energy from the other surfaces. Understood? This is the exchange of heat or exchange of radiant energy is continuously takes place. Okay. So if you consider one surface, and if this surface is receiving energy, radiant energy from all directions. Okay. So the total radiant energy received per unit time from all directions at all wavelength, that is known as irradiation. Have you understood? Yes.
Yes, sir.
Huh. And irradiations are doesn't depend directly on its own temperature, except when the radiation are received partly by the surface from its own reflected radiations. Okay. So if this surface is absorbing radiant energy from all direction in all wavelength, similarly this particular radiation get absorbed, that get also reflected out of that. Okay. So when any surface is absorbing or receiving the radiant energy in all direction, that some of the radiations are also get reflected from the surface. Some of the radiations are absorbed, some of the radiations are reflected, some of the radiations are get transmitted. Understood or not?
Yes, sir.
Okay. Similarly, radiosity. Radiosity means what? It is the total amount of energy emitted from the surface. Total amount of energy emitted from a surface per unit time. Okay. Irradiation means what? It is the total amount of energy received per unit time from all directions. Whereas radiosity means it is the total amount of energy emitted from a surface per unit time. Have you got the difference between these two? Yes.
Yes, sir.
Here there is a total amount of energy emitted in radiosity, whereas in irradiation it is the total amount of energy received, and this energy get received by a surface from all direction, not only one direction, from all direction and at all wavelength, because every wave having a certain temperature which is having a certain wavelength. Understood this? These are the two important concepts, that is irradiation and the radiosity. Okay. Then
Yes,
the properties of surface just now I discussed, that is absorptivity and transmittivity. Okay. So reflectivity means what? It is defined as the fraction of total incident radiation that are reflected by the material. So if Q, that is the total incident energy is there, out of that how much is get reflected, that is QR. Similarly, if total incident radiation is Q, out of that how much is absorbed. Similarly, how much is transmitted. Okay, so if you take a summation of these three, that is absorptivity, reflectivity and transmittivity. So QR plus QA plus Q tau divided by this Q. So QR, QA, QT, Q tau is basically equal to Q. So Q divided by this Q, that is equal to 1. Okay, so there are only three possibilities. Either the surface can absorb or reflect, or some of the get absorbed, some of the radiant energy get reflected, some of the get transmitted. It depends on the material, it depends on the surface properties. Understood? For example, if you have a white surface, okay. So what is speciality of white surface or that white color? Yes,
Good reflector.
Good reflector, white color.
yes, it is a good reflector. That's why we are wearing the white cloths in the summer season, because that is basically providing the comfortness to the human being. Okay, because the white cloths, okay, that are having a good reflectivity. So whatever amount of radiant energy that or the radiations get falls on that white surface, most of the get reflected. Ideally, reflectivity of that white surface is equal to 1. Ideally, ideally the reflectivity is equal to 1. If reflectivity is equal to 1, obviously the absorptivity and transmittivity is equal
Zero.
to 0.
Zero.
Zero.
Very good. So absorptivity and transmittivity is equal to 0 in case of ideal white surface. Ideal, practically the reflectivity is lower than this one, but it is compared to other surfaces which is higher. Now, if you wear a black cloth or if you have a black surfaces, so the speciality of that black surface is that it is absorbing the more radiant energy. For ideal black surface, absorptivity is equal to 1. So for ideal surface, if absorptivity is equal to 1, so reflectivity and transmittivity is
Zero.
equal to 0. Understood? Now if you consider the glass, if you let us take an example of glass. Now what is speciality of that glass?
It is a good
It is a
reflector.
good, it is not a good reflector. It is having good transmitting capability. Radiations get transmitted through that, isn't it? Radiations get
Transmitted.
transmitted through that. Okay, and you might have used some lens. Okay, so you might have did the experiment uh, in the school days. Okay, that you are using that lens and you are concentrating the sun rays through that lens, and then below to that lens we are just generally keeping that paper, and you might have saw that there is a burning of that paper. Yes,
Yes.
have you did this experiment?
Yes, sir.
Yes, sir.
This has been happen because the radiations get concentrated and it get transmitted through that. Because of transmission, this thing has been happen. So transmittivity of that ideal glass surface, that is equal to 1. So absorptivity and reflectivity is equal to
Zero.
0. Okay, so in conclusion, no surface is ideal one. No surface is ideal one. Every surface is having a some reflectivity, some absorptivity, and transmittivity. As far as the um, engineering applications are concerned, we have to choose the proper material from radiation point of view in the applications. Understood? Yes?
Yes, sir.
Okay, fine. Now, types of surfaces and body. Just now we have discussed the different surfaces, that is black surface, white surface. You can call it as a body also. Okay. So black body. Black body means what? That body absorbs entire radiation and it emits maximum radiations. Okay. So it is known as a black body. So ideally alpha is equal, absorptivity is equal to 1, reflectivity and the transmittivity is equal to 0. So black body is also a perfect emitter or the radiator of heat. Understood? Then opaque body. The bodies or surfaces which have negligible transmittivity, which have negligible transmittivity, so it cannot transmit that radiation. Okay? Ideally, so opaque surface is having a transmittivity is equal to 0, but it is having a reflectivity and it is having a absorptivity. So if you take a summation of these two, that is equal to 1. And the surfaces which reflect the total radiant energy, that are known as the white bodies. Okay. So reflectivity is equal to 1 in case of the white body or the white surface, whereas absorptivity is equal to transmittivity is equal to 0. Now, I already told that no body or the no surface which is ideal one. Okay. So the body which has its absorptivity is equal to emissivity. The body which is having absorptivity is equal to emissivity is called as a gray body, provided, this is very important, provided the temperature of the surface of incident radiation and the body are same. Have you understood this? Temperature
Yes,
of surface of incident radiation, temperature of surface of incident radiation and body are same. So body temperature and the temperature of surface of incident radiation, that has to be same. Then and then you can say that the absorptivity is equal to emissivity. Such a bodies are known as a gray body. Whereas the surfaces which transmit the radiation, like I already gave the example of glass, that are transmitting radiation, so that are known as a transparent surfaces. So in transparent surfaces, the transmittivity is equal to 1, so absorptivity and reflectivity is equal to 0. Have you got this up till now? Any difficulty? You ask me.
no,
Hello?
sir.
No? Okay. So now we have the 2 minutes. I am just revising the things I have explained in this session. Okay. So see, we have started with the thermal radiation. So thermal radiations are the radiation that are basically, or the energy that are basically flows because due to the electromagnetic waves without any physical contact, no medium is required. Understood? Then we have seen the two different theories that are basically accepted theories. First one is the wave theory, and second one is the first one is the wave theory, and second one is which theory we have learned? Quantum
Quantum
theory, or
theory.
you can call it
Quantum.
as a Planck's theory. Okay. Then we have learned the emissive power, that is Q by A, that total amount of radiant energy emitted per unit time per unit area. Okay. Then we learn the irradiation and the radiosity. Irradiation means it is the total amount of energy that are basically received by the surface in all direction at all wavelength. Whereas radiosity is basically the total amount of energy basically get emitted from the surface. Okay, that is known as radiosity. Then we learn the absorptivity, emissivity, and transmittivity, and then we learn the types of different surfaces and the body. Understood? Up till now, any difficulty you can ask me, so that in next session we will start the next topic of this unit, that is surface emission properties and different laws of radiation. Okay, any difficulty you can ask me?
No, sir.
No difficulty. Okay, so I am taking the attendance.